Hello. Let's see. I need to be sharing my screen. All right, there we go. Ta 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 ta. So, Today we're going to be finishing off the lecture on keystone individuals and animal leaders, and then we're going to wander into collective decision making, collective behavior, and cumulative culture in the next lecture, which will be Wednesday, Thursday, and then probably next Monday as well. All right, so I left off last lecture talking about how one or a few individuals in disease transmission networks are oftentimes responsible for the preponderance of secondary infections in a social group. And these are oftentimes referred to colloquially and academically as super spreaders, where some individuals, because of their traits, have an inordinate predisposition towards spreading diseases of one kind or another. And the kinds of traits that could facilitate a super spreader probably change based on the disease one is considering and the kinds of animal group you're contending with. So, for example, before I get into that, even in cases where there aren't super spreaders, like one or two individuals that are just like really infecting everyone, there's still a general rule in epidemiology called the 80-20 rule, which is the idea where 80% of the transmission events inside of an animal population or a social group are caused by an elite 20% of the individuals, which means that top 20% of the most infectious individuals that infect others cause the preponderance of transmission events, cause way more infections than the average individual. So the most infectious 20% are responsible for the lion's share of secondary infections and kind of inside of an animal social group, or even inside of an animal population that doesn't live in a highly organized society. So some individuals are more infectious than others, and that's always true. And the most infectious are particularly infectious, even if we don't call them super spreaders. And where we draw the line between that top 20% of infectious individuals and a true super spreader is totally arbitrary. In fact, people use them completely interchangeably. So I'm not going to ask you a question like, is this a super spreader or just the 80-20 rule? Anyway. So super spreaderness, which is not a word, depends on the transmission type and the social and biological circumstances of the animal society. So if you're inside of a cat population, like cats don't live in organized eusocial societies. They are not cooperative breeders, but cats do live in reasonably highly integrated social populations that, although they're not commingling panmictically and like rearing each other's offspring, they actually do they do recognize each other. They have individual recognition, and they have lots of affiliative and combative social interactions that still constitute a kind of sociality. So in cat populations, wild feral cat populations, the path of transmission changes which kinds of individuals are particularly infectious and likely to be in that super spreader or higher rate of transmissibility sort of category. So feline immunodeficiency virus, FIV, is a blood-borne pathogen that primarily spreads in wild cat populations through agonistic encounters, biting each other, bleeding on each other, cutting each other, etc. And what do you know? It's particularly combative male cats that are much more likely that if they acquire FIV to transmit it to lots of other individuals, both males and females, versus if you have cats that are on average male cats that are less aggressive, they're much less likely to, if they acquire FIV, to spread it to other males and to females because they're less likely to draw blood on combatants and on females. So, ironically, there is a link between the orange morph in male cats, orange coloration, and level of aggressiveness, so that the most aggressive males also tend to be orange cats, and so those are oftentimes the ones that, if they acquire FIV, are more likely to spread it in a more aggressive manner. Feline leukemia is not a blood-borne pathogen. It is a mucosal pathogen that's spread via saliva or snot. Well, super aggressive male cats, they acquire feline leukemia. They don't really spread it to all that many other individuals, but it's those demure, soft, deferential, friendly, low aggressiveness male cats that are much more likely to spread feline leukemia because they are more likely to engage in affiliative interactions like rubbing noses and allo grooming, which is much more likely to spread feline leukemia. So depending on the disease one considers, and the level of sociality and kind of sociality in various systems, you can see that completely contrasting traits can predict what's going to be a super spreader, can reliably predict what kinds of individuals are going to be super spreaders inside of animal populations. HAMs, hyper-aggressive males. Hyper-aggressive males are instances where males are just so aggressive, so antagonistic, so cross-contextually aggressive that they end up changing the social dynamics of their entire social group. So I've previously talked about male water striders where generally male water striders fight with each other for access to females. Female water striders want to be mated and then left alone. They want to wander around on the water surface, skating around, basically waiting for insects to land on the water surface. Then the female will slide over, skate over to where that prey item has been caught on the water, and then she will drink it with her little proboscis type mouth parts. Basically, water striders are like spiders that use the water surface as a web. So that captures their prey and then they consume it. Male water striders eat a little bit, but what they want to do for almost all day, every day, is find females to copulate with and then remain in copula with those females. How do they get those females? They beat each other up, males beat each other up for access to those females, and then they also try to force females into copulate, and females are larger and more powerful, so they are quite difficult to subdue for these males. But if they're a successful male and they're particularly aggressive, then they have a chance of forcing copulate on females, and then the female just sort of like tolerates the male as he hovers atop her and she skates around with him on her back. Anyway, it's all well and good to be more aggressive as a male, right? Because you're going to fight for access to females, you're more likely to acquire them, you're more likely to gain access to females who are even unwilling. The problem is that if you're just a little bit too aggressive, a little too zealous, you fall into a new category of male called hyper-aggressive males, which basically spend their whole time fighting other males and injuring themselves and frightening all the females off of the water column. So all the females will just run to the sides of the pool, and then that hyper-aggressive male has basically sterilized the whole social group. Nobody's mating, nobody's eating, the females are gone. It's like the 2 a.m. bar effect. All the males are just sitting around, staring at each other. And it's because that one or a few hyper-aggressive males have basically run away off of run off all the resources, which in this case are the copulatory events with those females. All right, so most males only episodically go into very aggressive males that are normally, advantaged, only episodically go into this hyperaggressive state for short periods, right? So about 20% of males will enter this state periodically for just a little while. But 1% of males are constantly in this state. They are going from social group to social group and circumstance to circumstance throughout their tiny little water strider lives, basically sterilizing any group they join. And these males aren't like enjoying, riches of copulatory opportunities themselves because they themselves are bad at coercing females. They chase females away. They're more likely to try to mate with a female's side or her face or her little insect face, her head, rather than actually approach the female from the right direction, skate up from behind her and copulate with her. They're much more likely to approach her from the side or the front and then just end up frightening the female. And so it is a total waste of their time. It is a total waste of everyone's time to have these hyper-aggressive males. So this is a great example where the little personality type of these particularly hyper-aggressive kinds of individuals can radically change the mating dynamics and mating system of their social group to which they adhere. And these water striders don't really have a lot of cards to play to force these hyper-aggressive males out. Sage grouse hyper-aggressive males, same story. They're just so aggressive. So sage grouse are like weird chickens, basically, that live out in the plain states of the United States and probably in Canada as well, though I'm not sure if they go that far north. Anyway, so from like northern New Mexico up to almost the Dakotas, out west to Idaho, Montana, and then possibly the southern plain states of Canada. I'm not sure. It's pretty cold and godforsaken where these animals live, so presumably they could also reside in the plain states of Canada. Saskatoon or something. Although, just to be clear, if you had a gun to my head right now and we're like, showed me a Canadian map, was like, where's Saskatoon? I'd be hard pressed to figure out where that is. Anyway, so enough of that. So more aggressive male sage grouse here, which basically use these giant vocal sacs and they bounce up and down while making a call to impress females or frighten off other males. Larger males and more aggressive males tend to acquire preferred mating positions in these giant mating aggregations called leks, L-E-K. So, oh, I guess it's on the slide. Look at that. So generally speaking, more aggressive males get a better position, usually in the center of the lek, and they mate with more females. The problem is that the most aggressive males, the males that are the most zealous, the most ready way with their attacks and attempts to mate, no longer are advantaged. And in fact, they can sterilize, again, the whole lek for short periods of time. These same males will attempt to copulate with 20 or 30 different females via force and are forced away every single time. They will initiate combat with males that are larger than them, more aggressive than them, who have a higher RHP, and so these males are more likely to be injured. These same hyperaggressive males will also do stupid things like mating with cow patties and mating with dead sage grouse, right? So it's these males are basically so aggressive that they are sterilized by their heightened levels of aggressiveness, and they sterilize other individuals as well. They're dangerous for everyone involved, and they waste a lot of time. I should say even smart sage grouse males are not that intelligent, because you can put a stuffed zombie sage grouse female on top of basically tank treads and have her wander around outside, and the males will try to mate with her easy peasy. And we actually learned a lot about the biology of sage grouse using robotic females, because males are dumb enough to try to mate with the new glassy-eyed chick. Turns out that if you make a male robotic sage grouse, the females want nothing to do with that robotic male, because they can tell, because females of these sage grouse, and indeed in many species, are discriminating enough that they can tell that this is in fact a robot and you can't fool them. Males, easy peasy. Trick them in almost any species, which is why most robots used in animal research are female robots to trick males. How about that? All right, so some of the questions you might ask yourself is like, oh my God, why are hams even a thing? How could they be adapted? Maybe under some narrow range of circumstances, it's actually advantageous to be a hyperaggressive male, or maybe hyperaggressive males are related to other kinds of males in the harem, or in the mating aggregation, that are advantaged narrowly in some relative way by the presence of these hyperaggressive males, or maybe hyperaggressive males are an anomaly, totally maladaptive, and that they, under normal circumstances, would have developed into a highly advantaged male, but they just missed an important developmental switch point, or had a certain kind of odd mating between a certain kind of female and a certain kind of male, which produced a genetic epistatic event and caused some anomalously hyperaggressive male. Nobody knows. Also, why don't other individuals inside these populations have counter adaptations, like to throw these hyperaggressive males out, or to quell them, or to kill them, or whatever, right? I mean, if these things are common enough, and indeed they are common in lots of different kinds of animal societies, why aren't there counter adaptations to limit their ill influence? There might be. Nobody would know. Nobody's tested it. And then there could be cross-contextual performance trade-offs. Maybe hyperaggressive males or hyperaggressive individuals are really, really advantaged in some other ecological context that we just haven't explored yet. Maybe they're really good at evading predators, or maybe they're really athletic, or maybe they're really good at fighting off diseases. Nobody knows. Your guess is as good as mine, or indeed anyone's. Leaders and followers. So probably the most famous kinds of influential individuals inside of animal groups are leader individuals, we think. So normally what they mean are movement leaders. And so that means like the individuals that initiate movements of the social group. Individual goes over here, other individuals follow them. So they're initiating a collective movement of a more highly integrated animal social group, like a herd or a school or a shoal or something like that. Schools of fish have highly directional movements together. Shoals of fish, S-H, how do you spell shoals? S-H, OALS, shoals, I think that's correct, have sort of like a more nebulous like cloud of fish that swim around each other, but aren't all that highly directed. So a school of fish would be like sardines, and a shoal of fish are just like some guppies hanging out together, kind of paying attention to each other. There are also, the way people use animal leaders, they'll refer to like tactical leaders or alphas or individuals that are in charge of the social group, but those may or may not be individuals at the front of the social group. You can imagine, like, at least inside of some of human societies, the individuals in charge are not the individuals out of the front of the army, right? At least not since like the Middle Ages, ideally. In fact, normally they, reside in the back. Presumably that happens sometimes in animal social groups, but we have no idea if that's true. Under most circumstances, we have no idea who are the most influential members of any particular animal social group. Although movement leaders, the individuals that start collective movements, we can tell who those are. And so that's why most animal leadership studies are referring to movement leaders, even if they don't say movement leaders or define what they mean. What they mean is movement leaders, the individuals that initiate collective movements of the group. Oftentimes, whether or not an individual is a leader or not is state dependent. Whoever is the hungriest is the one that's out there looking for food and is more likely to be at the front of the group looking for food, and everyone else just following them. It's often age dependent. The oldest individuals that know the migration route, that know this habitat pretty well, are more likely to initiate movements and go into areas unknown to other individuals, spatial areas, regions that are unknown to other individuals in their social group, and then the social group will follow them around. And it's often personality dependent, right? So the individuals that are the most bold, that are willing to go see what's over here first, are oftentimes the individuals that initiate the movement of the social group into new patches. Shy individuals, fearful individuals, they don't go wandering off, gallivanting into unknown areas where there could be predators. Let some idiotic, bold individual do that. So oftentimes it's state dependent, oftentimes it's personality dependent, oftentimes it's age dependent, oftentimes it also is determined by whether or not they have diseases. Like there are lots of parasites and things that make individuals bolder and more reckless. And so oftentimes those individuals are leading their social group at the front as well. So the dependence on state or traits can also be on the state, like, of other organisms that are manipulating the neural chemistry of their host. No one usually knows. All right, so most studies on animal leadership go a little something like this. We take a bunch of fish, like zebrafish or guppies or whatever, and we have them in a starting area. There's an obstacle that's hard to see through, and so whatever's on the other side is hard to detect and assess. And then we have some area that has food over here. And then we see which of these group members, these sinusoidal silhouettes, look at that alliteration, sinusoidal silhouettes is meant to be fish. And one of them might be a bold individual or an old individual or a certain sex of individual or have a certain parasitic level or whatever. And then we see which of those individuals are the first to move across that obstacle, whatever it is, and go colonize this new patch. This is usually an aquarium, or usually a shallow aquarium, so the fish can't occlude each other, and there's a camera over the fish, and then they see who initiates movement into this new feeding area to the right. Whoever colonizes the new feeding area, which attracts the other group members to realize that they can cross that obstacle as well, and that other individual hasn't perished, or they realize that you can traverse that obstacle at all and realize there's something else over there. The first individual that moves over is the leader. Everyone else that comes afterwards are followers. Now, is that leader particularly socially influential? Maybe if you take that individual away, that social group wouldn't explore new patches and would acquire less food. Maybe. Most of the time we don't really know. But reliably, there are usually traits or states about individuals that tend to initiate these movements that would make them more likely to be movement leaders. Occasionally, these are actually experimental studies where we have like robot fishes moving around that are leaders that we can control and manipulate, and then we're watching followership of everybody else. But as often as not, we're just recording fish under different scenarios, and we're just trying to figure out like how leadership and followership works by making really detailed computer-based observations of leadership and followership. So most experiments are lacking, and when they're present, there are manipulations to things like the geometry of patches to be discovered and whether or not there's things like alarm pheromones in the water, or whether or not there's a perception of risk from predators, or whether or not shadows have passed over them, or whether or not they're hungry, the social group is hungry or not, things like that. Those are where the experiments typically lie, but we're watching real life fish swimming around and trying to infer their little social rules, basically by perturbing the system on the outside and seeing how the fish respond. So we don't have like, fish can't self-report, and we typically are not manipulating important elements about the groups themselves to figure out whether or not leaders are actually influential. Some animals appear to lack social leaders. So this is an example of a tracking study done on chacma baboons. So we have little GPS collars on these primates, and we see them wandering around in space. Each of these little lines is the movement tracking behavior of an individual baboon that has this little collar on it. And they live in these arid landscapes, these thorn velds, which are basically like scrubby, crappy, unpleasant, thorny, arid environments that don't have canopies. They have mixed ground cover, low ground cover. It's very hot in the peak of the day, and so these animals are most active in the early morning and in the early evening, i.e. they're crepuscular. And so researchers were interested to know whether or not high social ranking females in these social groups were more likely to be weighted heavily during movement decisions. So when a social group is moving along in space and a new individual shows up and can either go right or left, is it paying attention to where dominant females in front of it have moved? Or are they just sort of engaging in consensus movement decision making, where they're just looking at where most of the recent individuals have gone and follow them? Well, it turns out that in these social groups, that's exactly what happens, that most of these baboons don't look at where the dominant individuals have gone. They don't look at where particular kinds of individuals have gone. They just see where the average individual of their group has gone and then follow that. And if individuals realize that they're not following the most common path of the social group, they go back to wherever that decision was, where they appear to have been left off from the group, and then follow the other route. So this is a great example of just how social cohesion basically creates the collective movement of these groups, and there are no specific leaders. The leadership is certainly not correlated with things like social dominance, but there's just general social movement rules that determine how these animals move through space. Everyone gets a turn being the leader because the leader is a role that is interchangeable with other individuals any moment in time. So one question you might ask is that, okay, so in animal societies that have really obvious movement leaders that are apparently socially influential, how did that evolve? Or how did it develop over the course of individuals' lives if it didn't evolve? So you might ask, are leaders particularly influential, or has the average individual in the population become more socially susceptible? So if some individual wanders off and nobody joins that individual was not a leader. Nobody followed it. So mechanically, in order to have a leader-follower dynamic, you have to have one individual move, and then somebody else has to follow it. So then the question becomes, when you have leader-follower dynamics, what happened? Do you have some individuals that are like, I now move, and I've got some sort of like little behavioral chain on everybody else that drags them along with me? Or is everybody else just like, oh yeah, someone moved over there, we better follow them a little bit? And is it followership that is the special sauce that makes leader-follower dynamics? So which trait is adjusted by evolution? Well, in social spiders, there are movement leaders that tend to have bold personality types. And bold individuals tend to initiate collective movement prey capture events for their social groups. But that leader-follower dynamic based on personality is only present at arid sites, at sites that have low prey availability, low incidence of predation, and there are relatively few places to build a colony of social spiders. At wet sites, there are still bold spiders, there are still shy spiders, but bold spiders aren't initiating movements and nobody appears to be following them. So the interesting thing about this is that you can use this leader-follower dynamic at some sites, but not others, to try to figure out what is special about arid sites. Is it because the bold individuals at arid sites are just particularly socially influential? Or is it because the shy individuals at arid sites have evolved to become lemmings, right? So what you can do is you can create chimeric societies where you take bold individuals from arid sites where they are socially influential, and we pair them with shy individuals from wet sites where they ain't following anybody normally. And then we take bold individuals from wet sites where they're totally unimportant, apparently, and then we pair them with shy individuals from arid sites where they at least have an evolutionary history of being lemmings. And so that allows you to figure out which trait is it about the leader-follower dynamic that creates animal leadership, at least in these social spiders. We have no idea about anything else. What you actually find out is that shy individuals from arid sites that have that leader-follower dynamic, they'll follow bold individuals from anywhere. And if you pair bold individuals from arid sites where they're particularly influential with shy individuals from someplace else, there's no leader-follower dynamic at all. So it isn't that bold individuals at arid sites have evolved to be greater leaders. It's that shy individuals, the population majority, have evolved followership. And that's what happened there. So what causes the leader-follower dynamic? What makes that particularly influential? Well, it appears to be that it's the followership of the population majority that has been honed by evolution or has changed as a consequence of development in some way we haven't yet figured out. So, hypothesized origins. I think I did a good job at timing this. I have no idea when this thing started, but I think it's about 30 or 40 minutes. Hypothesized origins. All right, so are leaders an evolved adaptive outcome of an animal society? When we are transfixed on political leaders or organizational leaders, inspired by them, mesmerized by them, horrified by them, we're still paying attention to them. And so is that tendency to pay attention to celebrities, to politicians, to popular members of our group, is that an adaptation? And whose adaptation is it? Is it helping me to go aspire to identify with, revere these other kinds of individuals? Or is it their adaptation that they're manipulating me? Or is it a group level adaptation that it benefits our whole society to have that leader-follower dynamic? Would too many cooks spoil the chili if you had too many leader individuals? And are individuals born leaders, or do they develop into them in these highly integrated animal societies? Nobody really knows. On average, we think that leadership is beneficial in the societies where it occurs, because if it weren't, they wouldn't do it. Like, they would evolve some other kind of social organization that didn't rely on leaders if it weren't on average beneficial. And if leaders were some sort of parasite, right, like manipulating everybody else, and on average leaders were bad for everybody else, well, that wouldn't persist for very long through evolutionary time, because there are more followers numerically than leaders, so there are more opportunities for mutations to occur in the population majority to not pay attention to leaders if they were costly, or to depose, extirpate, assassinate. Oh, I shouldn't say assassinate. I'm in the United States right now, so I'm scared like somebody's listening to me now. No one's listening to me. Maybe you guys aren't even listening to me right now. So, get rid of, depose these kinds of individuals. There's a larger population size of followers. Therefore, there's more effective natural selection because there's more mutations, and there's lower stochasticity, lower levels of genetic drift in such larger populations. And so this is akin to the same sort of arguments that you hear in like host-parasite dynamics, where there are many viruses and fewer hosts, so viruses evolve more quickly than their hosts, or in conflicting selection between individual versus group selection, because there are fewer groups, there are individuals, and group turnover is slower, and there's just more individuals than there are groups. And so there's more opportunities for, and a more efficient kind of natural selection that occurs in those social groups. Wait, how do I want to say this? So, in cases where there are more units and they are experiencing a higher mutation rate and genetic drift is weaker, natural selection should be more advantageous and effective. So, and if there's conflicts between a small population of individuals and a large population of individuals, the large population of individuals will tend to have their adaptations drown out the counter adaptations in the smaller population interactor. In this case, that would be leaders, because numerically, they're a rare phenomenon. They'd have to be. If everyone were a leader, there would be no leaders. Okay, so many unknowns. I've been harping on this the whole lecture, but like, under what ecological circumstances do you want key individuals to be present? In human societies, you might ask, What allows things like dictators to show up and become, and have, when you get social conformity and xenophobia to emerge, right? The sociologists, economists would love to know this. And it turns out it's not really rich societies that tend to have despotic leaders that emerge and xenophobia. It's not particularly poor societies either. What tends to occur, at least in human societies, at least in the preponderance of cases, are instances where a society was really advantaged, rich, wealthy, not that long ago, but then over the course of 1 or 1.5 generations, the society has gone from being quite wealthy and having lots of resources to having very few resources and being disadvantaged. And the fact that they have that memory, perhaps literal memory of individuals, but perhaps institutional memory of a generation not that long gone, that things could have been great and they're not great now. Things were awesome and now they're bad. And so they have that disparity between what they know is possible and what they're experiencing now. And that usually causes the level of leadership and conformity and xenophobia that we see in particularly worrisome nations traditionally. There are special circumstances that are orthogonal to that model, but that's what tends to be in human societies. And non-human animal societies, nobody knows. Nobody addresses this question. No one's got any idea at all. You could go address this right now. Go to grad school. Maybe don't go to grad school unless you're really into it. All right, so do some societies lack keystone individuals entirely? The answer is yes. We know that's true sometimes. But why? Have they just not had the opportunity to evolve this awesome adaptation, or is there something special about how their society works or their ecological circumstances surrounding it, their habitats, their evolutionary history? Maybe it would be awesome for anolis lizards to have keystone individuals and to follow them around in giant herds, and they just haven't had the evolutionary opportunity to evolve these traits because they have other kinds of adaptations that prevent these kinds of social structures from evolving. No one has any idea to what degree there are evolutionary constraints that prevent animal societies from having particular kinds of collective adaptations, adaptive organizational structures. There's a whole niche for organizational psychologists to enter evolutionary ecology and explore these questions. Nobody's ever addressing them. We might learn something about ourselves along the way. And even if we don't, it would be neat to know. So what happens when keystone individuals are problematic, when they have misinformation, when they're hurting the group? How do you depose and replace them? Can you stop trusting them? What do you do? And then what happens when there are multiple vying keystones that have different perspectives or different kinds of collective cultures that they're trying to impose or recruit in a social group? What happens there? How are those reconciled? How do followers determine who to follow? Nobody has any idea. These are interesting questions that you could address with fruit flies to manatees. Any system you could address these questions. It's just take somebody clever with time and a panache for doing the same thing over and over and over and over and over and recording what happens to figure out what the answers to these questions are. Maybe that'll be you. All right, so next lecture will be an intro to memetics. What is a meme? Not humorous picture of something online with some series of quotes around it. Memes are sad on average. I have lots of friends that show me memes. I worry about them sometimes. And not the memes, the people. Anyway, so we'll have intro to memetics from the perspective of cultural evolution. We'll talk about behavioral conformity and the benefits that it has inside of social groups. And you might think like, oh, I wonder if true behavioral conformity is actually really good for an animal society. And maybe it changes based on whether or not you're a wasp or a human society, and where would other kinds of animal societies fall on that gradient. We'll talk about behavioral innovations. What are those? What facilitates them? What's important about them? What kinds of traits about individuals make them innovators inside of animal societies? What are examples of animal innovators that exist that have been well documented or not so well documented? We'll talk about cultural evolution and juxtapose that to conventional evolution. And then we'll talk about cumulative culture, which is super duper fancy. And we like to think that in human societies that like we are the zenith of cumulative culture, which is probably true, and that other animals don't have it. Well, other animals do have it, and we've been able to show it experimentally, but we'll talk about common sorts of experiments that are conducted to evaluate cumulative culture in humans and manipulate those sorts of aspects of our sociality, and then we'll talk about the analogs inside of the animal world to whatever degree they've been identified. And then we'll talk about why it is great sometimes to make groups of organisms make decisions rather than individual organisms, because groups usually come to a better solution than an individual does. So how does that happen and why? Both statistically and then from not strictly numeric properties. All right, so I'll let you guys go at that. I hope you guys had fun in this lecture, and I'm looking forward to lecturing about collective dynamics on Wednesday and Thursday. Take it easy, guys. Have a good one. Bye. No, but for real, not. Goodbye.